Hello, my name is Badri Abdessalam, and the project I've selected is 600 Collins Street by Zaha Hadid Architects. This project is still unbuilt and is supposed to be located in Melbourne, Australia. As you can see, this building has 4 volumes. First, to generate the form of the first volume, I started off with a filleted rectangle, which I've later on extruded and capped. Now to manipulate this shape, I've deconstructed the B-rub and divided it into sections. To scale each section to the desired shape, we will need a graph mapper to scale each one from its center using an area component. Now that I have the shape I want, I've scaled item 0 up and culled out the old one to achieve a volume with a flat roof. And now, to create the fins that are on each volume, I've divided the curves equally and used flip matrix to create vertical curves. I've then created another filleted rectangle, but on a smaller scale, to create the shape of the fins. I've used this method to create the first 3 volumes. And the heights of the volumes can be controlled since they are connected to each other. Now for the last volume, since it has an angled roof and the fins are on the roof as well, it includes some extra steps, which includes taking item 0, scaling it up and offsetting it several times to create this roof-like shape that we later on merge together. And since the fins are going all the way up to the roof, we'll need to create an endpoint in the center. So I scaled down the item on the top. Now we can rotate. I then merged all the curves together and lofted them, which gave me the form of the 4th volume. Now for the fins, instead of dividing, I took the iso curves of the surface and used the sweep 1 component to create the fins. And now for the central part of this building, I used the polygon component to change the shape into however many segments I want. I then moved it up to cap. However, before doing so, I made it the same rotation as the roof by using the same angle that I've applied to the rotation component, making them parallel to each other. And then I capped it. Now moving on to the pattern part of the skin, I used the quad stag component, which I've divided by taking the number of fins and multiplying it by the preferred amount of patterns in between the fins. I've then taken the frames and smoothed it out using Weaverbird's Catmull-Clark component, which I've then thickened using Weaverbird's Mesh Thicken and smoothed it out with Weaverbird's Laplation Smoothing. Now this is what the form looks like with the fins as well as the pattern. Now for kangaroo, I started by taking the B-rub of the first volume and deconstructing it and used a mesh surface to turn it into a mesh. I also took the surface, evaluated it, and pre-parametrized to use an MD slider for the UV point to go around the entire surface. I connected that point to a sphere, which I then connected to a point in B-rub component to cull the points that aren't in the sphere. I then put the culled points to an anchor point as well as the naked points of the mesh and connected the mesh to the show, edge lengths, pressure, and smooth kangaroo components. These all go into the solver and create this bubble effect that changes the surface. Now for the fins connecting to the kangaroo volume, I used the topology directional component, which takes polylines from the flow of the object, which we then connect to perpendicular frames that are connected to the filleted rectangles. And with the sweep component, we will get the fins. This shows how this form can be manipulated in many different ways, like the way I used the box instead of the sphere in the second volume, and how the fins still follow this manipulation. The box is smoother since the box goes around the entire volume instead of just a small section of it. This shows how the form of the building reacts to different components. Thank you very much for listening.